Hi, I'm Papia. In this problem, we have to find a logarithmic equation that will relate this given x and y, where we have this table where the x values and the corresponding y values are given to us. So, since we want to find an equation with logarithm in it, we have to find the corresponding values for this x and y, the corresponding natural log values. So, for the given x, we need to first figure out the values of natural log of x. So, let's do that first. So, we have all these x values, plug it in the natural log function and find the corresponding values for natural logarithm. Okay, so let's start with the first one. When x is 1, natural log of x is 0. Okay, then x equals 2. So, natural log of 2 will be about 0.693. When x is 3, natural log of x is 1.099. X equals 4 gives us natural log 1.386. For x equals 5, we get natural log of 5 is 1.609. Finally, when x is 6, natural log of 6 is 1.792. So we have the column for natural log of x. We have to do the same for the y. So we have to find the values of natural log of y given these y values. Okay, so let's do that next. So we want to find all the ln of y. Okay, so let's start with y equals 2.5. So plug it in the natural log function. So natural log of 2.5 is approximately 0.916. Then the next value is 2.102. And natural log of that is approximately 0.743. Okay, then plug in y equals 1.9 and you get natural log of 1.9 is approximately 0.642. When y equals 1.768, natural log is 0.5698, so it will be 570 approximately. Next we have the value 1.672. So natural log of 1.672 will be 0.514. Finally, the last y value is 1.597. Plug that in the function and you get the value 0.468. Okay. So we have completed the table. We have all the natural log of x and all the natural log of y values. Next step is to plot these values. Which values are you going to plot? Is going to be the natural log of x and natural log of y. Don't look at the xy values anymore. We're going to plot these two. So you're going to imagine that this column with natural log of x, that's the x-axis. So those are the x values. And this column with natural log of y, those are the y values. So we will be plotting the points natural log of x, comma, natural log of y. Okay, so one more time, these are the x values, these are the y values. So here is the graph. On the x-axis, you have plotted all the points from the column natural log of x, and on the y-axis, you have plotted all the points from the column natural log of y. So you see those points, if you join them, it is a straight line. So in order to find this logarithmic equation that relates x and y, all we have to do is find the equation of this straight line. Well, recall, how do we find equation of a straight line? We need slope, we need a point, and we can write down the point slope form. And what points are we going to choose? Well, there are so many in this table. Just choose the first two if you want. Okay, so let's write down the equation of the line. Okay, so let's choose the 2 points. First one I want to choose is 0, 0.916, and second one, the second point, 0.693, 0.743. Okay, we can find slope easily. So remember, slope is the difference of y values divided by difference of x values. So in the numerator, you will have difference of the y values. So y2 minus y1, 0.743 minus 0.916. And denominator, difference of the x values. So 0.693 minus 0. Right? So let's see what the slope is approximately. Use your calculator. So you have 0.743 minus 0.916, and you divide by 0.693. And it's approximately negative 0.25 or negative 1/4. Okay, so you have your slope. You choose any of these 2 points. Let me choose the first one, and I'm going to write the equation. Now, be careful here. Notice the equation that we are writing, our x is actually natural log of x, and our y is actually natural log of y. So if you want, you can consider this ln of x is a big X, a different variable, and ln of y is like a big Y. Let's write down the equation using these variables, and then we'll replace them by natural logs later. Okay, so our equation will be, remember, y minus, we are choosing this point, so this is my x1 and this is my y1. So y minus y1, 0.916, is equal to m times, m is negative 1/4, x minus x1 is 0. Remember, these x and y, they are this different variable x and y. Okay, so now all you have to do is simplify this and then replace the x and y. Okay, so let's see. We will have y minus 0.916 equal to negative 1/4 x. You can bring the 0.916 on the right hand side. So you will have y is equal to negative 1/4 x plus 0.916. Okay, so we're almost there. One more step. Replace y by natural log of small y. That is the original y variable. That's equal to negative 1/4. X is natural log of x. And plus 0.916. So this is the logarithmic equation that relates the variables x and y. So we have our equation right here, but if you want, you can rewrite this one more time. Look at this particular constant, 0.916. Remember how we got that number? Well, go back to this table and see that 0.916 is natural log of y when y is 2.5. So this number is actually natural log of 2.5, which is same as 5/2. So this is natural log of 5/2. So if you want, you can rewrite this value in terms of natural log as well. So all we have to do is keep everything else same and just write down this number as natural log of 5/2. So what will the equation be? You just write down the rest of it. So you have negative 1/4 natural log of x plus natural log of 5/2, and this is equal to natural log of y. So same equation, just written another way. That completes the problem. Thank you.